Hello students, in this video we are going to discuss Cbse class 9 maths chapter 8 quadrilaterals. So in this we are going to discuss theorem 8.1. Okay, so this is coming under the properties of the parallelogram. So before this you would have learnt about the other concepts in this chapter regarding the quadrilateral and the properties of various quadrilaterals. So let's look at the first theorem, the statement. A diagonal of a parallelogram divides it into two congruent triangles. Okay, here we are talking about a parallelogram. Here you can see a parallelogram, and this parallelogram, the diagonal, for this you have two diagonals, one here and one here. Okay, in that one diagonal of a parallelogram can divide it into two congruent triangles. Here the important word is what? Congruent. You would have learnt about similar triangles and congruent triangles. Here this is congruent. Congruent means what? The shape, the size of the two triangles are going to be the same. If they are similar, only the shapes, but the size need not be the same. If it is congruent, it means the shape, size, everything are going to be the same. That is what we will have to prove in this theorem. Okay, so now what is given to us? The given data are that ABCD is a parallelogram. We are given a parallelogram ABCD. Okay, so this parallelogram ABCD. So this is the given parallelogram, and we are talking about a diagonal AC. So this is the parallelogram, and AC is what? AC is the given diagonal. Okay, so this is what is given. Okay, so now what do we need to prove? We need to prove that it divides into two congruent triangles. So what are the triangles here? Triangle ABC and triangle CDA. So we need to prove that triangle ABC is congruent to triangle CDA. Okay, so this is what we need to prove. So we are given that this is a parallelogram. If it is a parallelogram, we know that this and this are parallel. And you already learned in lower classes that if there are two parallel lines and there is a line passing through those two parallel lines, then we can say that the alternate interior angles are equal. That means this angle will be equal to this angle, isn't it? So in this triangle you can say that this angle C will be equal to, that is angle DCA will be equal to angle CAB. Similarly we can say that this angle will be equal to this angle. Okay, so we can say that. So now we are getting into the proof. So for the proof we know that BC is parallel to AD. So AC is a transversal. That is, the diagonal AC is a transversal. So in that case we can say that angle BCA is equal to angle DAC. So they are alternate interior angles. Okay, so what are they? They are pair of alternate angles. So you can say they are alternate interior angles. So similarly we are going to say about the other two angles. So what are the other two angles here? So we know it is going to be BAC. So BAC and ACD. Okay, so BAC and ACD. Okay, this is also the same case, and we know that in these two triangles we can say that this AC is going to be common. This AC is going to be common. So that is AC is common. Got it? So first we have triangle ABC. So let me draw triangle ABC here separately. This is my ABC. So this is my CDA. So what are all similar? Angle BCA. So BCA is equal to angle DAC. Likewise, angle BAC is equal to angle ACD. Likewise, and CA and CA are common. Okay, so in this case, so what we can say that, so from this we can say through the angle side angle. So this is another congruency rule. Okay, angle side angle rule. Okay, through the angle side angle rule, we can say that triangle ABC is congruent to triangle CDA. Is it clear? Yes. So that's it. So we are able to say that these two triangles are congruent. So thus we can prove that if we have a diagonal, okay, in the parallelogram, it will divide the parallelogram into two congruent triangles. Okay. Now shall we do a quick recap? Okay. So we have parallelogram and we have a diagonal. So we have it to be AB, CD. So we can say that AB and CD are parallel, likewise BC and AD are parallel. Okay, so we know that this is going to be a transversal. So this angle and this angle will be equal, this angle and this angle will be equal. So in that case you can say it is going to be a transversal. So finally we are talking about the two triangles ABC and CDA. Okay, so where we are able to see that CAB, that is this angle and this angle are equal, this angle and this angle are equal, so this side is common. So angle side angle, here angle side angle. So here we are using the ASA rule to prove that they are going to be congruent. Is it clear? Yes. So now we look into the textbook what is given in there. Okay, so this theorem statement is there. So now for the proof we are considering this ABCD to be a parallelogram and AC to be a diagonal. Okay, and then we see that it's going to divide it into two triangles. Okay, it is divided into two triangles, namely ABC and CDA. Okay, so A, B, C, D. Okay, so we need to prove that this triangle and this triangle are congruent. So here we see that BC is parallel to AD and line AC is a transversal. So in that case we are able to say about the pair of alternate angles since it is going to be a transversal. So RBCA is equal to DAC. Likewise your BAC is equal to DCA. Okay, so these are pair of alternate angles, and then we know that AC is equal to CA, that is the side is common. So we are finally concluding with the ASA rule that triangle ABC is congruent to triangle CDA. Thus we are able to prove that the diagonal AC is dividing this parallelogram into two congruent triangles ABC and CDA. Is it clear, children? Okay, so if you have any doubts, go through the video once again and try to rectify it. Okay, so see you again with the next theorem in another video. Thank you, children.